you all on. Are you able to see the screen? Yes or a no? Let me ask this question. And also, yep, wonderful, wonderful. Thank you so much for responding. And the next obvious question would be, are you able to hear me? Yes or a no? Can you all please respond to this? Excellent. No? Majority of y'all are able to hear me. As always, um, you know, I wish to do a quick internet check at my end, and I request every one of you to be, I want everyone else to watch my screen. So I do a speed test, and that's a speed test. So I'm having a very good internet speed. This is an indication that I'm using a very good internet speed. Look at that. So if there is any issue with the voice, or if you have any issue of the screen lag, that means there is an issue at your end. I request you all to fix this. Yeah, sure. I'm waiting for our team to join in. The moment they join, I am going to show the screen on where we have actually posted the quiz questions. One second. So what we shall do is, I am going to show you mind map. Okay, and here, if you go to drop down, you would see AI and deep learning. And when I click on this, you'll see AI and deep learning. And you have CRISP-DM, cross-industry standard process for data mining. We started off with this yesterday. And I'm waiting for our team to join. The moment they join in, I am going to post the YouTube link, and I'm going to share the details on where the quiz was posted yesterday. Okay, so just give me a minute. Just give me a minute, sorry. Okay, so we started off by discussing about CRISP-DM. CRISP-DM stands for Cross-Industry Standard Process for Data Mining, which happens to be one of the standard techniques in handling any of your AI, data mining, or data science projects. The first step is understanding the business problem. And once you understand the business problem, we record the business objectives and business constraints. Post that, you are supposed to, create a project charter, which is the first document which gets created on any project. Once you are done with that, you proceed further with data collection. As part of data collection, we have various data types. We discussed already yesterday about continuous data, discrete data. Within discrete, we discussed about categorical data, binary and multiple, and count data. Alongside this, We have also discussed about qualitative data versus quantitative, structured versus unstructured, big data versus non-big data, cross-sectional time series versus longitudinal panel data, balanced versus imbalanced data, and batch processing versus real-time processing. Do you know what? If you have balanced data sets, you can simply apply a simple random sampling. And if you have imbalanced data sets, you can apply any of these techniques. And then you have batch processing versus real-time processing. Batch processing versus real-time processing, let me explain quickly here. Say you have a database, bank database, wherein you have the information about all the people who have applied for the loan until now, all the customers who have applied for the loan. And using this historical data or past data, which is already available, wherein you have an output variable which explains about whether people have repaid the loan or not, whether the people have defaulted on the loan or did they repay the loan, did not default. And you have the input such as age, gender, income, right? And so on and so forth, educational qualification, etc. You get the data from the database and say you built a predictive model using Python or using R, you built a model. And that model would predict on whether a person will default or not default. You have this setup ready. Okay. Now here, if there is a new customer, customer A, who applies for the loan, and if you have customer B who also applied for the loan, and say you have customer C who has also applied for the loan, what usually happens is a specific bank might say that, do you know what? I'm going to collect all the loan applications which I get from 9 a.m. to 6 p.m. and I'm going to process all of these loan applications in a batch. Okay, so all the data, all the loan applications which are received by the bank in the morning from 7 a.m. to 6 p.m., you take all of that and process it once in a day at probably 7 p.m. So what are you ideally doing? You are taking the batch of applications, batch of loan applications, and you're processing those batch or group of loan applications at one go at 7 p.m. And then for each and every customer A, B, and C, when the information passes through your algorithm, machine learning algorithm, ML algorithm, then it will give you predictions such as there is 90% probability that a customer might default on the loan. This is for, say, customer A. This information goes back and gets recorded in this database as an additional column. And then for customer B, the information passes through and say the information is that there is 10% probability that customer B might default on the loan. So this information also goes and gets recorded in the database. For customer C also, it passes through your machine learning algorithm and you'll get another prediction. Maybe this time it says there is 50% probability that customer C might default on the loan. This information that gets recorded here then gets displayed on a dashboard. Loan officers who have to approve or reject the loan, they see all these details in a dashboard. In this dashboard, information will come in this way: customer A, B, C. Customer A, there is 90% probability that this person will default. So what do? You reject the loan. Directly you reject the loan. Loan officer will look at this: oh my god, there is high probability that this person will default. Reject. Customer B, there is 10% probability that this customer B might default on the loan, so you approve the loan because it's low chance, low risk. 50% probability, should I approve or should I reject? And this customer will actually, for this customer, the loan officer might say manual intervention, meaning do further research before you approve or reject the loan. So the point here is the data which is getting captured, you're taking that data and processing it in batch. It need not be once in a day. It can be 1, 2, 3 times in a day. Probably you'll say that, do you know what? At 11 a.m., at 3 p.m., and at 7 p.m., I am going to process this algorithm. I'm going to pass through the application details to my machine learning algorithm. So you're doing in batches. It's not real-time streaming. Now, for real-time streaming, it'll be slightly different. So let me explain. Say you have a specific database of a bank once again, and you have the details of all the credit card transactions of customers. So you have, say, customer A, say you have customer B. In that way, you have a lot of customers. And also, I mean, they'll be making use of credit card. And historically, you have data of millions of credit card transactions by thousands of customers. You take that historical or past data and say you have already built a machine learning algorithm using Python or R, right? You have built your machine learning algorithm. This algorithm will, say, predict on whether a specific credit card transaction is fraud or not fraud, fraudulent or not. Okay, fraud or not fraud. And then the moment this customer A does any transaction, it will go and get recorded in the database and say it spills out results saying that this transaction done by customer A is fraudulent, fraud. So this information goes and gets recorded in the database and real time it gets displayed on the dashboard of loan officer. So there'll be dashboard for them. Customer A, customer B, customer C in that way. And the loan officer would be sitting here. The fraud analyst. It will start blinking here saying that there's 92% probability that this credit card transaction is fraudulent. And this fraud analyst will immediately call this customer A and check, dear customer A, did you do this transaction? If customer A says, yes, I've done the transaction, you process it. If the fraud analyst says, no, I have not done the transaction, you decline it. Okay, you either approve it or you decline the transaction. Right? Say customer B has done a transaction, it goes through this and it says there is 1% probability that this could be fraud. It will get written back to the database. Since there is only 1% probability of this transaction being fraud, it will not raise an alarm. It will just go through. A few banks will call the customers to check, hey, did you do the transaction? A few banks will trigger an SMS alert. If you have done this transaction, press 1, if not press 2. A few banks probably will send out you email, they'll send you an email, it depends basically. A few banks will automatically decline. Next time, only if you call the customer service, they're going to enable that. So in this way, different banks have different ways of dealing with the fraud. But the point that you need to bear in mind is that here the processing and prediction and entire thing is happening real time. You cannot say that, do you know what, let me capture all these transactions and let me process all these transactions daily at 7 p.m. It will become reactive, right? Reactive means some fraud has happened, then you're investigating. You need to be proactive. So you need to understand on whether the business problem that you're handling requires real-time predictions or delayed predictions. Batch processing is also called as offline. Real-time is also called as online processing. So you'll have offline versus online. Next. That's batch processing versus real-time processing data types. Then once you understand about the business problem and once you understand about the data types and all the big picture that we have discussed until now, you proceed further with collection, data collection. Though this says it is primary and this says it is secondary, we should go after secondary data sources first. First, you need to go after what? Secondary data sources. And when you go after secondary data sources, you look at, okay, let me expand this. Okay, secondary data source is that data which is collected beforehand. Data already is captured. The examples that I've given of a bank is that data which is already available with the bank. Right? For example, data which is residing in relational database management system. 1 second, sorry. Is my voice not clear? Let me check this. Let me do a quick speed test. Let's do the speed test. Not really. I see a good speed here. I see good speed. I really don't know on what is the challenge in this scenario. It's 91.3 and 86.6. Is my voice clear? Okay, is my voice clear? Can you just let me know? Okay, clear. If majority of y'all are able to hear me, then I think issues are at your end. Internet issues are at your end. So let me pose that question again. Are you all able to hear me? Yes or a no? If majority of y'all are able to hear me, that means I would conclude that there is no issue. Wonderful. So since 85%, 88% of y'all are able to hear me, I am sensing that it's fine. And the speed test clearly proves, for those of you who are saying that it is cracking, etc. So uh, I would again like to show you the speed just to reinforce that I'm using a very high-end speed, and I use a noise cancellation mic as well. So I don't see any challenge here. So let's proceed further since 80% of y'all are able to, you know, hear me. It's 90%, 93% of y'all. Wonderful. So thank you all. So I think we should proceed further. Please check your internet settings once, friends. Okay. So secondary data source is data collected beforehand, meaning data is already available. It could be your organizational data, meaning companies or banks, etc., will already have the data, right? That's organizational data, data which is already available, like relational database management system, customer relationship management database, financial risk management, supply chain management, hospital management systems, SQL databases, so on and so forth. Also, there is data which is publicly available. One is organizational data. Another thing is data which is publicly available, open source data. You can also take that data. The greatest mistake which theoretical data scientists do is they assume that whatever data we get from the organization, that is final. But do you know what? Sometimes you also have to resort to open source data sources which are publicly available, get that data, and make use of these two data sources in building your model. Your model will be of very good quality if you do that. Another thing that people also do is they go after syndicate data sources and they take even that data. What do you mean by that? Let me explain. So do you know what? In case of telecom, say there is a telecom company which wants to launch a data plan, okay, internet data plan to people who stay in rural areas, village, countryside, okay, whatever you want to call that. How do you decide? I mean, do they just take the data of how people are using the internet connection in this region, in these villages? To what extent are they using? Do they look at only that? Absolutely no. They look at far outreaching data. You know, you can go and collect a lot of open source data, such as satellite imagery. Satellite imagery or satellite images. If I look at the satellite image of a village, and if you see that there is river flowing, if you see that there is river flowing, that means there is a lot of scope for cultivation. That means this village or rural area would be a lot more prosperous. So they'll have a lot of disposable income. That means we could potentially launch a high-end internet plan and start selling that to the people here. Another thing that people also look at, are the roads straight? That means people are very structured here, as opposed to road being like this, crooked. This is another indication to determine how prosperous a specific village is. And if you have neat structured houses like that, another indication. If you have big blocks like this, rectangular blocks, that means it could be a government building, an education building. It could be a school. It could be hospital. All these are indications that this village or rural area could be much, much more prosperous. When you combine your telecom company data of what plans people in this rural area use, couple that with the satellite images, you can do wonders. If you feel that satellite imagery is too high, I'm not getting clarity, then you can also go with syndicate data, which is data captured by drones. Drones fly on top of the villages and then you can capture the images. Of course, there are a lot of restrictions pertaining to drone, but then, yeah, that's why it is syndicate. Syndicate means you buy data. From data aggregators, you go and buy the data. This is what theoretical data scientists today lack. 99% of people who are getting trained on data science and AI are so hell bent upon learning algorithms that they lose the big picture. Ultimately, they become um redundant in the market. They become obsolete. If I were to interview them, I would not hire them. Certainly, I'm speaking. I'm echoing the voice of a lot of chief data scientists. The challenge that we face is we get a lot of theoretical data scientists. They learn a lot of algorithms, and they claim that they can work on projects which they cannot. And that is where you know you need organizations and people who have that practical knowledge to train you. All right. Next, this data is easily available. If you take the same example of telecom company, if you ask the telecom firm on, hey, can you get me the details of all the people who use my telecom services in this village, they will give you that data. It's easily available. But the disadvantage is that data which the customer has or the open source databases may or may not have the variables needed for your analysis.
Mm.
If you do
Mm.
not have the data needed for your analysis, oh, sorry, one second. I think there's some background noise. Someone from Task has joined. I would request you to please mute yourself. Right. Thank you. Okay. So data may or may not have variable of interest. If you do not have the data needed for your analysis, then you resort to primary data source, wherein you try to collect the data at source. I'll give another example, practical examples, and hence I call this as practical AI and deep learning. The programs that we conduct are all practical oriented. We have worked with a client from US, which is specialized in providing education loan. Okay, here it's very unlike Indian context, wherein parents take the responsibility of education loan and everything. Their students take responsibility. Parents are not really bothered about whether students are repaying the loan or not, okay, to a very great extent. So this specific financial institute in US, they were saying that, do you know what? We have all the historical data, okay, of you know how many students have applied, did they repay the loan or not, did they default or not default, their age, their gender, which college they have applied for, their entrance exam marks, so on and so forth. But they were saying that this is not foolproof in building prediction models or predicting on who are the students who might default on the loan. Then we asked, why do you think so? They were saying that, you know what? Majority of the students who are applying for the loan are applying for the loan for the very first time. So I have absolutely no credit history. I don't know their credit status. If there is a student who has already taken a loan, and if that student has repaid, then I understand that this student is worth going after. Okay, but here we don't have that information. So what we have done is we have resorted to primary data collection because there were a few points, data points or variables which we needed to make this model very comprehensive. So we resorted to social media extraction. So what we have done is we have gone to social media. There are a lot of things that you need to understand about social media before you extract the data, right? And do you know what? We extracted the data pertaining to number of friends that that student has, which is called as degree centrality. Degree centrality. Then we have also extracted the data pertaining to the posts that that person does. Using those posts, Facebook posts, comments, Twitter tweets, okay, so on and so forth, and we could figure out on whether this person always tweets, posts, or comments about positive things, or does this person post or comment or tweet about negative things? About what things? About what or what emotion does this person echo? That's called as emotion mining. We've also done this emotion mining. And then we've also, looked at various other things such as, does this student who applied for a loan always posts about international travels, about partying, or is this student gadget freak that he will always purchase the newest of the gadgets which are released in the market? iPhone 12 released, he will be the first person to buy it. And what do people do? They post on social media saying that, do you know what, I purchased this. Wonderful, but companies are observing you. And if you're a spendthrift, etc., do you actually have the propensity to repay the loan? Can you actually repay the loan? Do you have the capability to do that? And this has won us amazing accolades. On CIO review, we won the top 10 companies in US for 2018, right? Thanks to these kind of innovative things that we brought in. So all we have done is we did not simply bank on the data given to us by the customer. We have gone overboard to get the data from primary data sources. That is, we extracted the data from social media. You can do web scraping, you can do surveys, design of experiments, simulations. You can install IoT sensors to get the exact appropriate data. The greatest advantage with primary data collection mechanism is that you get the exact data needed for your analysis. And the flip side is that it is costly and time consuming. Okay, it is costly and time consuming. There is cost benefit analysis. There is no free lunch theorem. Hey, tell me A, B, C, D, job done. No, there's nothing of that kind which exists on the planet, unfortunately. Okay. Once you collect the data from primary and secondary data sources, you're done with data collection. But do you think the data which came to you is of good quality? No, it need not be of good quality. Hey, then what should I do? You have to resort to data cleansing or data preparation, which is also called as data munging, data wrangling, exploratory data analysis, which is also called as descriptive statistics, feature engineering. You perform all of these tasks. Can I clearly delineate between 3A and 3B and 3B and 3C? Can I delineate among these steps? Absolutely no, you cannot. All these three are overlapping. Just for sake of simplicity, we have named it this way, but they are pretty overlapping. In data cleansing, data preparation, data munging, data wrangling, you have a bunch of techniques. Bunch of techniques. And then you have exploratory data analysis. Again, a bunch of techniques. And then you have feature engineering. So what I shall do now is I'm going to quickly walk you guys through a few of the data cleansing, data preparation, munging, and wrangling tasks, which would come in extremely handy when we get into our machine learning algorithms and discuss about, the bunch of neural network algorithms. Okay, all of these. I mean, of course, we'll not have time and energy to do all of these things, but then, yeah, majority of these, at least a few of the most important things we will theoretically understand. Okay. Before we get there, we need to understand step 3. So back to step 3. This is exactly how you do a project. I'm not saying this. European Union is saying this, and a lot of industry experts. For the last 15 years, trust me, I have been working on crisp DM, and it wonderfully works well. The success rate of your projects just explode. Okay. Data cleansing, data preparation, data munging, data wrangling. Here, the first thing that you need to understand is outlier analysis, which is also called as outlier treatment. Hey, what do you mean by that? Okay, we are getting there. And there is a term that I personally coined, which is called as 3R technique. I haven't seen it anywhere. And if someone has copied from me, I'm not sure about that. Okay, so the 3R technique, I'm going to explain about this. Say you have data, sales data. Okay, and you have month. In the month of Jan, say the sales was $10,000. Okay, and in the month of Feb, say the sales was $12,000. In the month of March, say the sales was $8,000. And in the month of April, sales was $1 million. Wow, $1 million. So if you observe carefully, this appears to be a number which is very different than the rest of the numbers. These kind of numbers which are extremely large or extremely small in comparison to the other data is called as extreme values or outliers. Okay, it's called as extreme values or outliers. The question is, what do you do with such outliers? You as an AI expert would check with this, sales department or finance department or accounting department on, hey, why do you think there is such a big number? One of three things happen. Your finance person might say, oops, do you know what? Accidentally I've added 2 zeros. Thank you for bringing it to my attention. And this guy would remove these 2 zeros. So you're rectifying it. Or your finance person might say that, hey, do you know what, AI expert? We have hired a new marketing head. And this marketing head is a brilliant person. He has helped us put together an innovative marketing strategy. And because of this innovative marketing strategy, our sales just exploded. Oh, wow. Then your question to that person would be, wonderful. Do you think This innovative marketing strategy is something that you want to continue into the future. If the question is yes, then you retain this, because if this innovative marketing strategy would continue into the future, then these kind of values will appear in the future. So you want to retain this value in your analysis. The third thing is remove. So if you check with that salesperson or finance person on, hey, is this an outlier? Why is this such a big number? And if your finance or sales people say that, do you know what? There is this lousy marketing head who joined us. He told that there is an innovative marketing strategy. He made us, do you know what? Spend $1.2 million on this. And we got only 1 million in return. And the board of directors are planning to just dismiss him, terminate him. Oh, is it? So you'll not try out any such marketing strategies in the future? Oh, yeah, we will not try out. If you're not going to try out, remove it, because you will not find these kind of numbers in the future. 90% of them that I've interviewed, okay, when I check with them on what is your definition of outliers, they amazingly explain that. But when I check with them on what do you do with those outliers, do you know what? They give me just one answer. We remove it, we delete it. Outliers give you a lot of scope to analyze, right? So outliers shouldn't be deleted just like that. And I serve as a chief data scientist on 4 companies. I would give absolutely zero tolerance if someone is going to delete the outliers just like that for fun. They cannot say that, do you know what, I identified that this is an outlier using box plot, so I delete that. No, you should not do that. Precious data is precious, data is oil. There might be very interesting insight lying there. Those are the insights which are like diamond. That is what management needs. Okay, next. So, I mean, if you have less number of data points, analyzing each and every data point and understanding why is that an outlier absolutely makes sense. No doubt about that. But then, if I give you a million records, 1, 2, 3, 4, a million records. Do you know what? When we have done project for Korean Airlines, I think roughly there were 30 million rows. 30 million rows, and it was based on cargo. How much space is getting filled? Out of 3,000 cubic capacity, is 2,900 cubic capacity getting filled, or whatever be it? So 30 million rows, and there were at least maybe 10,000 odd outliers. If you were to analyze all the 10,000 outliers, it would take 1 year, because a few were dated back to 4 years, 5 years. You need to get in touch with the right person and check why is that an outlier. Is there a guarantee that that person remembers what happened 3 years down, 3 years back? Absolutely no, right? So what do you do in these kind of practical scenarios? Once again, I'm telling you guys that this will be practical oriented. Theory, I'm sick of theory, unfortunately, right? That's why our book that we have launched is also practical data science. It's not theoretical data science. Anyways, back to this. So what you do is, ideally, you take this data and you represent it in a visual format. When you represent the data in visual format, you can resort to something called as box plot. And box plot appears like this. Do not worry about box plot, and that's part of data science stuff that we deliver training on. Okay, anyways, say this is a box plot. Any value which falls below and any value which falls above would be called as outlier. If you have a lot of data points here, and if you have a lot of data points here, you treat all these data points as a different segment of data. You treat it as a different data set A and treat it separately, analyze it separately. You treat this segment of data separately. This is data set B, and treat this and analyze this data separately. And all the non-outlier data, this, treat it as another segment or as another data set, and start analyzing this separately. This is a practical way of handling it. There are two more techniques, a bunch of techniques, but then two more important things is what we are going to discuss here. And what we do is, there is a technique called as Winsorization. What happens in Winsorization is that, let me remove all this and let me explain here. So this is the minimum value. This is called as quartile 1. This is called as quartile 3, and this is the maximum value. In Winsorization, okay, Q1 means, even before that, Q1 means 25th percentile. Q3 means 75th percentile, so on and so forth. I'm sure you all are professors, lecturers, so you are aware of percentile. On a score of 100, if the maximum that a student has achieved, the maximum gold medalist is 98. So you will start treating 98 as 100th percentile. And relation to that, you treat the other values. I'm sure you are aware of that. I need not even speak about that, right? Anyways, that aside, here in Winsorization, you have an option wherein all the values, I mean, you can say 5th percentile at the lower side, and you can get hold of, say, 5th percentile is somewhere here. Okay, and get hold of 95th percentile on the upper side. Here, somewhere here, you'll have 95th percentile. So you'll have 5th percentile and 95th percentile. You force fit all the values which fall here, you force fit all these values to 5th percentile. And then you force fit all the values which are above this 95th percentile to 95th percentile. If there is a point here, you force that value to be this same value. A value here, you force it to be this value. A value here, you force it to be here. You will force all these values to lie here, and you'll force all these values to lie here. So you're forcing it, right? This is called as Winsorization. There is also another technique called as alpha trimmed technique. Alpha trim technique is that you will say, hey, I want to trim off 5%. So what happens is all the lower 5% values and all the upper 5% values are trimmed off, removed. That's called as alpha trim technique. And you forget about that. You just take the, so what you do is basically, if you have data like this, the lower 5%, it need not necessarily be outliers. It can be the regular data also, and the upper 5%. These also, not all values could be outliers. A few might not be outliers. So you get rid of those. Okay, and then you start handling the middle 90%. Okay, this is how you do. You handle the outliers. Outlier treatment. This is how you treat. All right. Next thing is we have missing values. Missing values means if you have a specific data set wherein you have a column called as age, and say you have another column called as gender, another column called as income, so on and so forth. If you have the data like age is 32, gender is male, income is say $28,000 or 28,000 rupees, my bad. Okay. And then say there is another person, age 36, female, 52,000 rupees. And then you have another person, 28, male, and income value is missing. And then another person is of age, age is missing, gender is female, and then income is 61,000 in that way. And for another thing, you know, the age 18, gender is not known, salary is 8,000 in that way. 18, you know, child labor? No. Okay, let me make it 22. That would be better. All right. So here, this value is missing and this value is also missing. What do you do with these missing values? If you have those missing values, and if you give this data as is to your machine learning algorithm, do you know what your machine learning algorithm would do? It would simply delete this entire row. So entire row will be deleted. If entire row gets deleted, then you're also going to lose these values. You have values for gender and age. You would be losing those values. That's a risk. Okay. And here also it will be the same. You have a value missing here. So what would happen is, if you do not replace this with any logical value, then the entire row will get deleted. If the entire row is getting deleted, it becomes again meaningless. Same is the case with this row also. So what should you do? You have to do something called as imputation. What is imputation? Imputation is replacing the missing values with some logical value. For example, if you have a column called age, what you do is you take 32, 36, 28, 22, all these values, and take an average of all those values. Say the average turns out to be whatever, 30, assume. So what you do is you replace this missing value with 30. Simple. Here also you have income, right? You take all these values, take an average of all those values and replace this missing value with average value. And when you replace the missing values with average value, it is called as mean imputation. But when you have categorical data, such as male or female, you cannot ideally replace the missing value with some value, or you cannot take an average, right? So what you do is you just replace this with mode, maybe. So here say age is 23, it's female, and 26,000 salary, right? So what you do is you look at mode. Mode is that value which repeats maximum times, right? So for, yeah, so choose. So you have 1, 2, and 3. Mode is female for this. So what you do is you take female and replace this missing value with female. values, and the technique used to deal with missing values is called as imputation. And what do you do with missing values? You replace the missing values with some logical value. That's called as imputation. Simple. There are other imputation techniques also, but then mean and mode is what we discussed. Then you have certain transformation techniques, right? You have a few things we cannot actually discuss in detail. So I'll just be theoretically touching those. And then you have something called as discretization, binning, or grouping. It is very, very simple concept wherein if you have data called as income, if you have say 28,000, um, 26,000, 81,000, 1,60,000, so on and so forth. You have the data, assume 8,000, 50,000, etc. You can simply create different buckets or groups. You can say if the income is less than 30,000, people belong to category 1. If the income is greater than 30K and less than or equal to say 85K, you would say these people belong to category 2. And people who have their income greater than 85K would actually belong to category 3. So you have the categories here. So 25,000 is less than this, so you say category 1. 26 is also less than 30,000, category 1. 81,000 is in between 30 and 85, so category 2. 1.6 is greater than this, so category 3. This 8,000 is less than category 1. 50,000 is in between category 2. So you have converted the continuous data into discrete. This is continuous data. You're converting that into discrete count data. The process of converting continuous data to discrete is called as discretization or binning or grouping. Okay. There are a few more things which we need to discuss. We will certainly discuss those, but even before that, let me go here. Okay. Where is the YouTube link? Yep, YouTube link is here. My dear friends, professors and lecturers, you will get access to the videos on the YouTube channel. All these videos are being recorded. Please make best use of that. And towards the end, we will also post a WhatsApp link. You can join those WhatsApp groups. If you have already joined, don't worry again. You need not join again. If you haven't joined, join, because we'll be communicating more on that. And one more very important thing, I need not second this at all, that please subscribe and please click on notification the moment there is a new video uploaded, any new video on any concept. You can just be notified and then you'll not miss out on that. Just subscribing doesn't help. Subscribe and also click on notification. We conduct amazing trainings on Python programming and all that. You'll simply be amazed at the kind of quality that we maintain, right? Can you all please do that? I'll be sharing it right away with you all. Yeah, there we go. I request you all to do that. It's worth it. Trust me on that. Okay. Yeah, how will it become meaningful? See, all we are doing is Kanakam, Sadi Kumar, we are trying to replace it with some logical value. If you do not replace it, the entire row gets deleted. But then I just introduce that. Missingness in itself is a 4-hour session that we conduct. There is K&N imputation, regression imputation, hot deck imputation, and all that, right? I mean, for our ease of understanding, if you just understand this, it's good enough. We have to focus more on AI and deep learning concepts. So that's the reason why I'm not doing a deep dive. Yeah, deep dive is a different thing altogether. Hope that answers your question. Yesterday's second session is not posted. Second session, it was only for 2 hour, one long session, Sarita. Okay, next thing is, yeah, this Facebook, right? Sorry, LinkedIn and Facebook. Uh, See, social media extraction is extremely good. You'll all be teaching your students on social media extraction. But for that, we need to at least understand what are the various concepts which exist, right? Okay. So I request you all to follow the page and then it will be posted somewhere. Let me see this 10 hours back. Yeah, here we go. Here is a quiz. Yesterday's quiz. I request you all to participate. 34 people have commented. That means 34 people have participated actually. It's a good thing, right? For you all also, for your students, when you want to ask questions, etc. Yeah, here we go. You have a ready-made set available. Make best use of that. Okay, and please follow the page so that you get to see all the future things. And then Facebook. Yeah, sure, I can. So you want me to post this link, is it? Let me see. Okay, so here we go. If you want to answer that. Okay, next thing is Facebook. On Facebook also we post, but please do not forget to once again follow so that it's not for my own benefit, right? It's for your benefit also because we keep posting new things. People from IBM, we launched the programs in collaboration with IBM. So people from IBM are going to conduct certain sessions. You will love it. Okay, and in this also we would have posted. Let me share that link also with you guys. A lot of sessions happen. It's just going to be amazing for you guys. So where did that go? Published 9 hours back, 10 hours back. Should be this somewhere. Come on. Come on. Yeah, here it is. So do I have option to copy it or edit more? No. Okay, let me see more options. I think I cannot. Oh yeah, here it is. I think I can share. No, I don't have that option here. I think I can copy it, but then that option is not available here. So that's okay. You can just see that question and answer that. You can just post your answers in the comment section. Yeah, sure, we will do it. Sadi Kumar will do that. No, what continuation session, Abdul? I didn't quite get you. This session is for 2 hours. Yesterday also it was for 2 hours. Let me see here. On which part wasn't appearing? Oh, I see. After the glitch. Okay, we will get it posted. I get you. I get you. I'll get it posted. Sorry, I didn't see that. I get you. All right. So, friends and faculty members, what we shall do is every hour we shall be taking quick 10 minutes break so that we don't get disturbed. So it's 6:05 now. Let us all assemble at 6:15 once again and we'll complete the remaining part of it. Yeah. Break time until then. Please take a break and come back. Okay, let us continue here. So we have to now discuss about something called as normalization standardization. We use this technique called as normalization or standardization for, there are three techniques basically. We use it to make the data scale free and unitless. What do you mean by that? What do you mean by standardization? And what do you mean by normalization? And there is also something called as robust scaling. Okay, but we will discuss about these two: standardization and normalization, which is also called as min max scalar or range method. Okay, so let's move on and understand better. Okay, so these three techniques, out of these three, these two is what we are going to discuss. To understand that, I need to get into a data set which is called as um, car data set. Cars data set. Let me look into desktop. Let me type cars data set. So let me open this and let me explain about normalization and standardization. Let me zoom it. Say you have two columns called as top speed and weight. All right. Now here, for now, just mimic or pretend as if you know about linear regression. Just assume for now, okay, that you know about linear regression. And in linear regression, when you build this model, say you want to predict mileage of a vehicle, and you have horsepower, volume, top speed, and weight. Say you have these four, and you need to predict your mileage. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. So mileage is equal to, you'll get some numbers, okay, like probably 1.8 plus 1.6 into horsepower plus 1.75 into volume, okay, plus 1.9 into top speed plus 1.8 into weight. In this way, you'll have some numbers. Given these numbers, which of these inputs will have the least influence on mileage? If I were to ask you such a question, then obviously your answer will be weight. You'd say, you know what? Weight will have the least influence on mileage because weight has the least numbers. Among all these inputs, X values, weight has least numbers. That's 28, etc. Here it's 104, 89, so on and so forth. So weight will have the least influence on mileage. Let me write it down here. Least impact on the mileage. And which variable will have the maximum weightage, maximum impact on your mileage, miles per gallon? It'll be top speed because it has 3 digits and nowhere else you find that. So top speed will have the maximum impact or greatest impact. Weight will have the least impact. Top speed will have the maximum impact on mileage. Just because of the scale or units. It shouldn't work that way. Why? Because say we are measuring the weight here in kgs. Assume if I were to measure now weight in pounds, same weight of the vehicle is the same. I'm just trying to measure it in pounds. So if you take this and if you multiply it with 2.2, 1 kg is equal to 2.2 pounds. 30 kgs is equal to 67 pounds because you multiply each kg with 1.2 to get the units in pounds. Now, same vehicle, just because you have now measured in pounds, what will happen if you substitute instead of 28, if you substitute 63 in this equation, what would happen? 1.8 multiplied by 63, not 28. So your mileage will increase. Is this how your data set should behave? Wherein, if you measure the weight in kgs, you will get less mileage. If you measure the weight in pounds, you'll get more mileage. Is this how it has to work? No, it should not be working in this way. Right? So units should not be impacting your output. Hence, to solve this problem of scale, wherein you have 3 digits, 2 digits, just because this is in 3 digits, mileage will be more. Just because this is in 2 digits, mileage will be less. It should not impact in that way. Scale should not impact your output. And units also should not influence your output. So in order to make your data scale free and unitless, in order to make your data scale free and unitless, we are going to apply a technique called as standardization. All we will do is say x minus mean divided by standard deviation. If you do x minus mean by standard deviation, you'll get the answer. Let's see. Let me now delete this basically. Let me calculate mean and let me take it here. Let me calculate mean and standard deviation of top speed and weight. Mean is nothing but average of top speed. You get that. Mean average of weight is so much. Then standard deviation of top speed is so much. And standard deviation of weight happens to be so much. Why did we calculate mean and standard deviation? We calculated mean and standard deviation because I need to apply this formula. X minus mean by standard deviation. So if you want top speed, you just say X. X is here minus mean of top speed divided by standard deviation of top speed. Then remember only X changes now. X minus mean of top speed divided by standard deviation of that. Again, I repeat the formula. It is X minus mean divided by standard deviation. In all these cases, the X value is changing, but mean and standard deviation is remaining the same. So ideally what you can do is X minus mean. Mean value is not changing, so you can select that and press F4 on your keyboard if it's Windows. Divided by standard deviation. Select this and say F4. Okay, when you do that, oops, it's in that case, yeah. When you do that, you're standardizing this column. And do you know what? The beauty of standardizing is that when you standardize, mean will become 0 and standard deviation will become 1. We will check that. Certainly we'll check that. But let me also do this for weight. Formula is x minus mean of weight divided by standard deviation. Again, it is x minus mean of weight divided by standard deviation. Remember, mean and standard deviation does not change. Only the x value changes. So x minus mean divided by standard deviation. Again, x minus mean. So mean is not changing. So I'll ensure that it's the same. It doesn't change. Divided by standard deviation. So there we go. We have the standardized top speed and standardized weight. Now if I calculate the mean of top speed and standard deviation of top speed, it will be 1. How about weight? Mean of weight is so much and standard deviation of weight is 1. We have mean and standard deviation. Now you might say that, hey, you told that mean will be 0, but is it 0? No. Oh, hold on. Here, this can be written as 5.28795. Not just Excel, any statistical programming language which deals with numbers. If you have a number which is very lengthy, it's going to compress that number by including this E. So you say 5.28795, multiply it with 10 raised to the power. This E means 10 raised to the power minus 15. So you write it as 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 5, 2, 8. Is this not 0? 0.00000. Is it not 0? It is approximately 0. Same is the case with this number. Wherein you write this as 2.27527, when you have E minus 16, you write it as multiplied by 10 raised to the power minus 16. So this would be 0.1234, all the zeros, 227. It is approximately 0. So you get a 0. That means whenever you standardize, okay, you get mean equal to 0 and standard deviation equal to 1. Simple. Mean 0, standard deviation equal to 1. This is one way of ensuring that you're making your data scale free and unitless. Standardized scaling, x minus mean by standard deviation. When you apply this, mean equal to 0 and standard deviation equal to 1. And you have something called as min-max scalar or range method. And the formula is x minus minimum value divided by max minus min. Okay. And when you apply this formula, no matter what is the minimum and maximum value of your underlying data, the normalized data will have minimum 0 and maximum 1. Let's try out this also. Okay, so I will remove these two columns, and of course we will remove these. Then instead of these, I'm going to make it minimum and maximum. If you go to any column, you can calculate the minimum value of that. So I'll calculate the minimum value of top speed. Minimum value of top speed is 99.56. And maximum value of top speed happens to be 169.59. Then if I were to find the minimum value of weight, is 15 point something, and maximum value of weight happens to be 52. Now, what is the formula? Formula is x minus minimum value divided by maximum value minus minimum value. Simple. So let's apply this formula for top speed. Again, the formula is the same. It is x minus minimum value divided by maximum value minus minimum value. Let me put brackets throughout. Yep, that's the number. Again, it is x minus minimum value divided by maximum value minus minimum value. Again, I'll do the same thing. X minus minimum value divided by maximum value minus minimum value. Again, the same thing. X minus minimum value divided by maximum value minus minimum value. Maximum minus minimum, right? So I'm ensuring that minimum and max values remain the same. Top speed, we are done with this. Let's take weight. Weight is again the same. X minus minimum value divided by maximum value minus minimum value. These max min values will remain the same, only the x changes. So I'm going to select this, press on the key F4 on the keyboard, and it will put those dollar signs. That means for rest of the cells, only the x value changes. Wherever you have the dollar sign, those won't change, meaning min and max values will not change. Now, if you calculate the minimum value, you will get 0, and maximum value will be 1. For weight also, the minimum value would be 0 and maximum value would be 1. That's it. It is pretty simple, pretty straightforward. You have the minimum value and you have the maximum value. And minimum is 0, max is 0. That means no matter what is the minimum and max value, no matter what is the minimum and max value for the various columns, when you standardize, you get 0 and 1. Simple. Okay, this also is done. The next thing is dummy variable creation. When it comes to dummy variable creation, we are almost done, by the way, yeah, with respect to these data cleansing techniques. When it comes to dummy variable creation, the most widely used is one-hot encoding, then label encoding, etc. But one-hot encoding is very important. When we discuss about neural network algorithms, we will perform one-hot encoding. So let me explain about one-hot encoding. And people who feel that math is difficult, I'm going to make it very simple for you all. Just pay attention here. If you have a column called as gender, wherein you have male, female, okay, in that way, female, male, all these details. You have a variable which is called as a factor with two levels. Any variable which takes limited set of values is called as a factor. And this factor has two levels. What are those? Male and female. So it has two levels. And then you can create a dummy variable for this. And you can say male is 1, female is 0. Why female 0? Why male 1? Are you being biased? No, I'm not being biased. Lexicographical order means alphabetically what comes first in some sense, right? Of course, it looks at all the alphabets. So F comes first, then comes M. Alphabetically, A, B, C, D, E, F, G, H, I, J, K, L, M. After F comes M. So whichever comes first will be given 0. Whichever comes next would be given 1. Let us say there is another variable called as make of car. Okay, and then in make of car, say you have a lot of variants such as petrol variant, diesel variant, CNG, LPG, so on and so forth, then CNG, then diesel. In that way, you say you have the data. Then you create dummy variables. You create petrol, diesel, CNG. You need not create for LPG. Why? I'll explain. This is petrol variant. So against petrol, you'll put a 1. Rest will be zeros. LPG also will be 0 if you had LPG. For diesel, you put a 1 against diesel and rest you put zeros. When it comes to CNG, for CNG, you put a 1, rest will be zeros. For LPG, it is neither petrol nor diesel, nor is it CNG. So it is assumed that if it is not these three, it will be the other level, which is LPG. Again, you have CNG. So it's a CNG vehicle, you put a 1, 0. Diesel, you put a 1 against diesel. Okay, so now you have make of car, which is also a factor because you have limited set of values. And this factor has how many levels? 4 levels: petrol, diesel, CNG, LPG. Unique levels are 4. So it has 4 levels. If you have a factor with 2 levels, how many dummy variables did we create? 1 dummy variable. If you have a factor with 4 levels, how many dummy variables did we create? 3 dummy variables. Question to you all, I request you all to respond please on the chat window. If I have a factor with n levels, how many dummy variables would I have? If I have 2 levels, I have 1 dummy variable. If you have 4 levels, you create 3 dummy variables. My question is, if you have n levels, how many dummy variables do we have? I request everyone to please respond on the chat window. It's a humble request. I request everyone to please reply on the chat window, friends. Let me have a look at that. Wonderful. Now tell me who told math is difficult? Look at this. A lot of y'all are responding. I'm seriously interested to know on who told math is difficult, right? Absolutely. If you have n levels, you'll have n minus 1 dummy variables. You can give a pat on your back because you just became mathematicians. You derived a formula for me. This is how mathematicians derive formula. It's not that they sleep and oracle comes and whispers in a ear saying that, you know what, n levels, n minus 1 dummy variables. No, they do it. They experiment. They start small and slowly and steadily they increase the number of data points and they generalize it with a generic formula. And then you can claim that you are mathematician. That's it. It would have been become difficult for y'all if I would have told that. Do you know what? Um, Always you have to create n minus 1 dummy variables. Then you are like, oh, okay. But now at least you will understand. And every problem in math, if you can solve in this way, small, slightly big, and generalize, you'll remember for your rest of your life, and you can yourself derive such formulae henceforth. Okay. Then there are other things which, of course, we train as part of our data science training and full-blown training. So I will not touch every nook and corner because of lack of time. Not that I don't want to. Yeah. And then we have feature engineering. In feature engineering, you have something called as feature extraction and feature selection. We will not get to feature selection, but we would certainly discuss about feature extraction. Within feature extraction, you have automatic extraction and manual extraction. Of course, principal component analysis, factor analysis. There are a bunch of other techniques which exist. But let's discuss about feature extraction. Let me take this aside. Again, I would need your help in doing this, and you will do it. Let's see. Say I want to predict on whether a credit card transaction is fraud or not fraud. And say you have inputs. Which customer has given you? Input 1 is time of previous transaction. Then you have place of previous transaction. Then you have, say, third input, which is time of current transaction. And you have place of current transaction. Say you have 4 inputs. Now there is something called as Occam's razor. It is an English term, okay? Occam's razor or principle of parsimony. These two are English terms, my dear friends. And these two mean that simplest of the techniques, simplest of, in our context, simplest of the model is the best. It's not that, hey, I'll make my model look very, very complicated. Absolutely no. Simplest of the model is the best. Occam's razor or principle of parsimony means the same. Now, if you take all the 4 inputs and build a model, your model will look like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. But then I can do something mathematically with these. What can I do? Let's see. If you simply take x1, which is time of previous transaction, and x3, which is time of current transaction. Say the previous transaction was done at maybe 6:40 p.m. and the current transaction happened at 6:45 p.m. So when you subtract these two, you get 5 minutes, and that's called as time lag. So using these two, you come up with a new variable called as time lag. That's the time between two transactions. Place of previous transaction. Say previous transaction happened in Hyderabad and the current transaction happened in Bengaluru. 600 odd kilometers distance. So if you subtract these two, you'd get another variable which is called as distance. And using these two variables, if you build a model, your model will appear like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2. Forget if you don't know what this equation means, okay? That's some equation, some mathematical equation, okay? Assume. Now, using these two variables, you can come up with one single variable, and which is nothing but velocity. And velocity is equal to distance upon time. So distance divided by time. Wonderful. So using these four variables, I could compress those somehow using my domain knowledge into a single variable. And if I have a single variable, I can use only velocity to predict fraud or not fraud. And hence the equation will be y is equal to beta naught plus beta 1 into x. This is the simplest of the model that you can build, thereby satisfying Occam's razor or principle of parsimony. Feature engineering at its best. Feature engineering means, or feature extraction is a component of feature engineering. Using the existing variables, if you can come up with more meaningful variables, right, that is called as feature extraction. Manually, you have done it, right? There's another example that I can give you. Say you want to predict on whether you want to give loan to one of these people or not, person A and person B. And you have the details such as their debt. Debt means how much money they have to repay to the bank. Debt. Say person A has a debt of 20,000 rupees. Every month person A has to pay to the bank 20,000 rupees. Person B every month has to pay to the bank 1 lakh rupees. Oops. Too much of debt for person B. Whom would you lend a loan? Would you lend a loan to person A or to person B? Obviously, you cannot make a comment just by looking at the debt, because there is another important variable called as income. Say person A has an income of 25,000 and person B has an income of 10 lakhs per month. Now, whom would you lend a loan to? Person B, because after paying 1 lakh, this person B still has 10 lakhs left out. But person A, after paying 20,000, would have only 5,000 left, because from 25,000 they pay, person A pays 20,000. So 5,000 is left out. Risky. Okay. So, and not nowadays, since ages, we have this CRISIL score, CIBIL score, etc. Okay. And those CIBIL scores and all are extracted, but people couple that with the social media data and other data to make informed decisions. Right? A few banks still rely on CRISIL or CIBIL score. They are substandard banks. I'll give you an example of the three banks. Okay. Say you have HSBC Bank, State Bank of India, and Standard Chartered. Say you have three banks. You want to predict on whether you want to lend loan to a person or not, given these two inputs. If there are substandard theoretical data scientists sitting in a bank, they will ruin the bank. How? They will take the data, they will say, okay, let me treat this as y and these two x, and they'll come up with an equation. They'll build a prediction model. Wonderful is what people think, but that's one of the shabbiest jobs which a data scientist can do. Hey, why are you saying that? They've used debt and income. Hold on. Feature extraction, please do not forget that. Your number one enemy that you have to go after would be your raw data that you receive from your customer. Using that as is a sin. Okay. Say people in HSBC are slightly knowledgeable. What they do is maybe they'll come up with a new variable which says debt over income. They will divide debt by income and they get only a single variable now. So when they build a model, it is beta naught plus beta 1x. Good, but not, so I would say good, better, best. State Bank of India. I mean, I'm not in the literal sense, but since we are Indians, we have to support Indian banks, right? So that's the reason. SBI. Say SBI has smartest of the brains. And what these smartest of the data scientists or AI experts do is say they take income on y-axis and the number of people, population, okay, and say they plot it. A lot of people will have low income group and middle income group. Only a fraction of people will have very high income group. Like your COVID-19 cases, right? What happened to COVID-19 cases? Earlier it was less, then slowly it became exponential, right? The growth in COVID-19 cases is exponential. On similar lines, when it comes to income, income follows exponential distribution. Data are distributed like an exponential curve. Debt also follows exponential distribution. Check with any economist, he would say, or it's also common sense driven. A lot of people are going to fall under low and middle income group. Only a fraction of people are filthy rich, pink rich. Okay. Linear means like that, straight line. Exponential means like that. People say, right, that if you learn Java, .NET, etc., your growth will be linear. If you learn data science, AI, your growth will be exponential. You choose. It's one life. You'll not have 10 lives to lead. Within one life, what is the best that you can do? I would go with exponential on any given day. Okay. If you have exponential data, you can capture the pattern of exponential data. You capture usually the patterns of exponential data using log. So what you do is basically you come up with another variable which is log of debt divided by log of income, and you start treating this as a new variable. You start treating this as a new variable, and then if you build a model, you will say y is equal to beta naught plus beta 1 into x, where x is simply put log of debt divided by log of income. Simple. When you do this, you will reach the highest levels. Friends, banks which are very stable, etc., would also have the same data which is available with the banks which go bankrupt. Same data. The only thing that is going to differentiate is how are you going to analyze that data? 99% of the cases, I'm sure people who train do not train in this way. because they themselves do not know. Okay, I mean that's a fact. Anyways, so look at the credentials whenever you undergo the training. Needless to say that credentials of the trainers, tutors. Okay, so that's feature extraction. And what did we do? How did we extract? Manually, we have extracted. It is time consuming, of course. It is time consuming. But the good part is, you know the variables that you extracted. Okay. But then, and then you use your shallow machine learning algorithms. There is a revolution going on in the world, which is called as deep learning. Your deep learning, which is synonymous to neural networks, the beauty is that it will automatically extract the features for you. So it'll be super fast. Speed. You might spend days together to perform manual extraction of features, the exercise that we have done. Since we have done it long back, I was able to do it quickly, but then it will take time if it's new data. You need a lot of domain knowledge. But when it comes to deep learning, it will automatically extract the features and hence it is fast. But then do you know what? It is also called as black box technique. What does that mean? In flights, you'll have the black box, right? They take black box only at the time of flight crash to analyze what went wrong and all that, right? But nevertheless, here you will not you will not come to know will not come to know on what new features were extracted. You know in the manual process that it is log of debt by log of income. But here you'll not come to know on what are the new features which were extracted. That's the challenge. Okay, so you do a cost benefit analysis, speed versus you knowing the variable, exploratory power, right? You will be able to explain the variables here. Here you will not be able to explain the variables. But here it is time consuming, here it is fast. Which one do you want to take is a call that you take. But when we proceed further, we will discuss more about this. Now, explainable AI. I mean, a lot of people are doing research on that. It's the buzzword now. Explainable AI, where people are trying to explain on what new variables are being extracted, etc. What do you mean by weights and all that? If that becomes true, then trust me, all your shallow machine learning algorithms such as KNN, decision tree, random forest, whatever be it, all of those will be put in a dustbin and world will be only using neural network algorithms. And that is the reason why AI and deep learning is worth investing your time in. It's worth it. That's the future. Who knows, in the next 1 year, 2 years, by the time you train your students on typical data science concepts, all those concepts become, you know, redundant, no longer usable. Hence, it's worth investing your time and energy on this. Okay. Now, yep, here is the form. You can give your attendance on this. And YouTube link is anyways shared with you all. Once again, I'm requesting you all. Otherwise, you might be complaining, right? So subscribe, please, and click on notification to be notified about all the new videos. Okay, please do not forget that. And today also we are going to post our quiz questions on both Facebook and LinkedIn. And you can simply, take the questions. You can answer. Where do I answer? On the comments. See, a lot of people have answered. 23 comments. I request you all to just answer. It's going to enhance your knowledge at the end of the day, not my knowledge, right? So on the WhatsApp groups, we will be posting. Be active, and thank you all so much. There's a question now. People working on some technology will model itself build the ML and DL algorithms. Yes, it's happening, but not to that extent that you're speaking about, Kranti. To a great extent, yes. All right. And people who want to connect with me on LinkedIn, yesterday a lot of people have connected. Friends, we are all professors, lecturers, etc. So we have to be active on social media because social media extraction is one big thing. Okay, so if you don't have an account, create one. You need not stick to social media, but it is worth being there on social media. You need to know all the various functionalities. That's my LinkedIn profile. Do connect with me. Thank you all so much. So, Shivani, yesterday I explained the difference between data mining, machine learning, etc. Tomorrow also I will do that. Yesterday I explained that. We'll upload that part. I think that part is missing, Nagaraju. We will update that on the YouTube channel. Yeah. Yesterday we have discussed that. All right, my dear faculty members, thank you all so much. See you tomorrow. Bye until then. Yeah, sure. We shall share everything on the YouTube channel. Thank you.